Okay, in the previous videos, what we have done is we have looked at noise characteristics in general, and then we have talked about uh, how filters or different system functions would affect the noise when it goes through the system. We've talked about noise in resistors, and in this video, what I want to do is I want to talk about how noise is inherent in op amps, and how do we account for the noise that op amps generate or add on to the signal that they are processing. And we will call that the op amp noise model. Okay, so here is an op amp, and the easiest way of thinking about the op amp in terms of noise would be to think of a noiseless op amp, so which is the ideal kind of op amp, and added on to that you have a voltage noise and you have a current noise that is added on. Okay, so INN is the current noise at the inverting terminal, and INP is the current noise at the non-inverting terminal, and En is the voltage noise. So imagine that these three noises are added on to this noiseless op amp, and that's what gives you the real op amp that you're using. The values of INN, INP, and En can actually be found in the datasheet of op amps. Usually, what we find is INN and INP are much smaller than the voltage noise. Okay, and so we may ignore these, and we will say, let's say, for the purposes of our course, we can imagine our op amp noise model to be just this voltage noise. Okay, so along with the noiseless op amp, we have this voltage noise added on, which you would have to account for. Now, what does that mean? That means that if you are making an inverting amplifier, you put three resistors for an inverting amplifier, right? Or maybe two. So let's say I have added this resistor here. So along with each resistor, you will have some noise, right? We have already looked at the thermal noise in resistors. And in addition to these noises at the resistors, you have a noise, the voltage noise of the op amp as well. And now having these noise sources, you can calculate what the output is going to be. What the output is going to be because of this input, and what the output is going to be because of all the noise sources at the output. And we'll do some calculations like this as a practice so that you get a hang of what we are doing here. Okay, of course, the the noise in the op amps is going to be dependent on frequency. Okay, so what we usually want to do is, when we are choosing op amps, one of the criteria that we choose op amps in would be to say, well, what kind of signal do I want to use this op amp for? Okay, is the noise in that frequency range low or is it high? So for example, in this particular op amp, you can see that the noise is quite high near the zero frequency, right? At very low frequencies, the noise is high. While at very high frequencies, the noise is quite low. So you may say, so I can use this op amp for this particular range, but probably not for this low range. What you would, of course, find is that most op amps have this characteristic. So you'll just have to compromise, and